Hello. Sorry the last video ended kind of abruptly, but I had meant to continue, and I did continue, and then I realized I was tired. My brain was fuzzy. I made mistakes. I thought, you know what? The first half was all right. I'm going to send that to you. Now I'm refreshed. I had some lunch, attended 3 meetings, so I'm ready to go again. I'm going to show you the rest of them. Okay, here we go. Now these are all multiple choice questions. Now I gave these to you just so that you can kind of see how the answers look and kind of remind you how to do things in case you've kind of forgotten them. It's been a while. All right, we want to know where the function is increasing or decreasing. So basically, we're looking at the derivative. When the first derivative is positive, that means the slopes are positive. The function's increasing. When the slopes are negative, that means the function is decreasing. So function going up, function coming down. It's all about their slopes. So what do we want to do? Right between that up and that down, we're looking for that 0, or potentially if it doesn't exist. Now in this case, it's just a parabola. And it doesn't take a whole lot to realize a parabola is going to have one value. And if it's a parabola like this, it's going to have a minimum. But let's go ahead through and figure it out. So we take the derivative, 8x plus 2. It's never going to not exist, but it will equal 0 at one point. So subtract 2 from both sides, divide by 8, and we're going to get negative 1/4. Now that kind of makes sense, and we got negative 1/4 all over the place here. So the question is, where is it increasing, where is it decreasing? So an easy thing to do is put that negative 1/4 on a number line, because that's the point where it's going to equal 0, and see what's happening on either side. Check the derivative, not the original function, because the original function just tells me what the point is. I don't really care what the point is. I care if it's going up or down. So I got to find the derivative. So pick any number you want greater than negative 1/4. 0 is a fine number. If I plug in 0 to this, I get a positive number. I get 2. If I plug in a number less than negative 1/4, it doesn't matter what you choose. Some people pick negative 1. I pick negative 100. Whatever you feel like. So you pick negative 1. 8 times negative 1 is negative 8. Negative 8 times plus 2 is negative 6, so it's negative. So remember, negative, the function is going down. Positive, the function is going up. So it's going down before negative 1/4, and it is going up after negative 1/4. I don't know if I said positive last time. It's negative 1/4. Okay, that's how you do increasing and decreasing. All right, what about local extrema? Well, local extrema means maxes and mins. Now, it says absolute extrema, which means this graph, again, it's another parabola, on the interval -6 to 6, what is its absolute maximum value over that interval, and what's the absolute minimum value over that interval? Well, remember, if it's an interval, it could happen at either endpoint. Okay, so we should put those numbers in and find out what happens. Now, I tell you, when you put in -6, you're going to get -2. When you put in 6, you're going to get 70. So is 70 the highest that this function reaches? Is -2 the lowest that this function reaches? Well, the only other thing to check is its local maxes or mins. So check its derivative. That's not the derivative. How silly of me. The derivative of this function is 2x plus 6, which means it will equal 0 when this equals 0. So we subtract 6, divide by 2. So -3 is its local max or min. So we have to check -3 also. And when I plug in -3, I will get -11. So I think it's clear here that the absolute minimum value happens at -3, and it is -11. And the absolute maximum value is 70. So that gives us the answer of, let's see, so our min is -370, and I'm sorry, -3, -11. Our max is this, so it gives us this one. Okay. All right, let's keep going. Oh, concave up or down. That's a second derivative. Second derivative tells us concavity. If it's positive, I better fix that. That doesn't look so good. Okay. So if it's positive, then it's concave up. And if it's negative, it's concave down. So take our function here. Now I gave you ones that were pretty straightforward. I didn't want to like crush you with the mathematics. I already did that with some of those derivatives from the previous problems. I just want you to see the applications. Now you might be able to figure it out already. If like, oh my gosh, that's a parabola again. It's negative. I know it's going down. I know it's concave down. But here's how I use calc to prove it. So set this equal to 0. Oops, I don't set it equal to 0 yet. Silly. That's just the first derivative. We have to take the second derivative. The second derivative would be -8. All right, there's nothing to set equal to 0. There are no what we would call points of inflection. This is simply -8. The second derivative is negative. So if the second derivative is negative, it's always concave down. So it's concave down everywhere. There's your answer. All right. Let's move on. Now, where is this one increasing or decreasing? Well, that's kind of a nasty looking problem. We got to the 6th power, to the 3rd power. Ew. So increasing. We want our derivative to be positive. Then we know it's increasing. So let's take the derivative. It's a product rule. The derivative of the second, plus, and we reverse it, the derivative of the first times the second. Now, that looks pretty ugly. However, it's very factorable. So what I mean by that is, all right, they both have I'm going to take a 3 out. You see why? I can divide that by 3, divide that by 3. What else do they have in common? They have x plus 3 terms. There's 6 of them here, there's 5 of them here, so I can take 5 of them out. And they have x minus 1 terms. There's 2 there, there's 3 there, I can take out 2. So what does that leave me left with? All right, the 3 took it out. X plus 3 took out 5 of them. I have 1 left. X minus 1 squared took it out. We're done. 6, I took out 3. So that's going to leave me with 2. X plus 3, I took them all out, all 5. X minus 1, took 2 of them out, so I'm left with x minus 1. So I've got this. I've got 3, got x plus 3 to the 5th, got x minus 1 squared, and this is going to be x plus 3 plus 2x minus 2. So it's going to be 3x plus 1. Okay. That's my first derivative. Set it equal to 0. It's going to be 0 at -3, at 1, and at -1/3. Hey, look, -3, -1/3, and 1. We got all the points. All right, let's determine where it is increasing. -3, -1/3, and 1. Not to scale, but doesn't need to be. All right, we're going to check the derivative again. So we're going to check values here. Now it's easy to figure that out. We got three things. Well, we got four. 3 is always positive. We're checking about their signs. This could be positive or negative. That's squared. So guess what? That's always positive. And that could be positive or negative. So pick a number greater than 1. Pick 10. 10 plus 3, 13 to the 5th. Definitely positive. Definitely positive. 30 plus 1, definitely positive. And 3 positives makes a positive. How about a number between -1/3 and 1? Well, let's try 0. 0 seems pretty safe. If I plug in 0 here, I get a positive answer. 0 here, I get -1, but I'm going to square it. Positive answer. 0 here, oh, I got a positive answer also. And it shouldn't be too surprising because at 1 here, number 1's a double root, and a double root means you have the same value on both sides. So these should be negative and positive. Let's check it out. Pick a number between -1/3 and -3. Say -1. All right, -1 plus 3 is positive. This is positive. But -1, -1 times 3 is -3 plus 1. I get a negative. So two positives and a negative make a negative. And a number less than -3, say -100. -100 to the 5th power, oh, that's very negative. Well, -100, not -97 really, but it's negative. This is always positive. -100, that's going to be negative. A negative times a negative gives you a positive. So it's increasing before -3. It's increasing between -1 and 1. It's increasing from 1 to infinity. Oh, there's a little typo there. I kind of meant to make that a 1. Sorry about that. It's a little confusing. The reason it really technically is not -1/3 to infinity is because at 1, for that brief moment, it's not increasing, but it flattened out to 0. So sorry for that mistake. I've already sent this, so I'm just going to have to deal with it. I apologize. Okay. All right. Whoops, wrong way. There we go. Number 15, Local Extrema. So again, extrema means maxes or mins, and local is just our critical numbers. So take the derivative. We get 6x squared minus 18x. I want to find out where it equals 0. So I'm going to factor out what, a 6x. Leaves me with x minus 3. So my two critical numbers are 0 and 3. And I test. 0 and 3. Pick a number greater than 3. Put the little squiggles. It's kind of fun. Like 5, positive, positive. Like 1, positive, negative. And like -1, negative, negative. So remember, it's going up, then down, then up. So it's got a local maximum when it goes from positive to negative, so at 0. And when I plug in 0, I get 2. So that's my max, my local max. And then going down, coming up, my minimum is at 3. When I plug in 3, I get -25. That's my minimum. So my max is 0, 2. My min is 3, -25. And I think I have that right here. All right. Cool. Cool. All right. A couple more to go. What? Is it just one, actually? It's just one. Oh, thank goodness. Now, a tangent line. Remember, tangent line means you need two things to get a line. You need a slope. And we find that slope by taking the derivative. So we're going to be finding the derivative of this. And we need a point. And we have the x value of our point. So if I plug in 1, what do I get? Well, 1 plus 3 is 4. The square root of 4 is 2. We'd have 4 over 2, which is 2. Our point is 1, 2. Now we just need to find the slope. Now, I don't know about you guys, but I prefer, this is just me, I prefer using product rule over quotient rule if I can. So I'm just going to rewrite this as 4x times x plus 3 to the negative 1/2 power. Just a preference. You can do quotient rule, that's fine. Doesn't matter because you're going to get the same answer. The reason I don't care about which way I do it is I'm not going to worry about how easy it is to simplify. Because once I take the derivative, I'm going to leave it in its ugly form and just plug 1 in for x and find my slope. So that's the first times the derivative of the second. So it's negative 1/2 x plus 3. I'll lower that by 1, so it'll be negative 3/2 plus the derivative of the first times the second, which is just, whoops, how about I actually do it right? The derivative of the first is 4 times the second, which is x plus 3 to the negative 1/2. Okay? At this point, I'm going to plug in 1. I'm not going to worry about simplifying it. So we'll do each part separately. We'll take this part, plug in 1, I get 4. Just going to bring this negative 1/2 down. Okay. All right, I'm going to plug in 1 to this. Don't let this get you. Remember, these are not that hard. Just think about it. Plug in 1. 1 plus 3 is 4. So 4 to the negative 3/2. Remember, the negative 3/2 means that's your power and that's your root. So if I had 4, what's the square root of 4? Well, it's 2. And then what's 2 cubed? Well, it's 8. But the negative means it's 1 over 8. Okay? So that's what that becomes. Plus 4. And then I'm going to plug in the 1. 1 plus 3 is 4. 4 raised to the 1/2. So the square root of 4 is 2. But that negative root means it's 1 over 2. All right, that's everything. Let's put it all together. Okay, so 2 times 8 is 16. So it'd be negative 4 over 16 plus half of 4, which is 2. All right, I know 4/16 is really 1/4. But to add that to 2, we'll make that 8/4. There's my slope of 7/4. That's where it comes from. That's a positive 7/4, right? So it can't be this one, can't be this one. Now I got to find the equation of my line. And you know me, I like point slope form, and I don't know why. You other classmates might deny. Sorry. That song's been around since I was in college. All right, so there it is. But you notice it's not one of the answers, so I got to solve it for y. So 7/4 y minus 7/4 plus 2. All right, so what's 7/4 plus 2? Don't forget my x. Negative 7/4 plus 2. So 2 is, sorry, my brain went crazy for a minute, is 8/4, right? So negative 7/4 plus 8/4 is 1/4. Sorry, it's squished down there, but there it is right there. So forgive my mental lapses and my inability to add fractions and my complete disregard for your sanity by quoting a song from the 80s that was redone, I don't know how many years ago. Anyway, I think I'm done. I think I'm tired. I think I need to stop. So tomorrow, Leah will go over this review. If you have any questions, please drop in the live session. And I hope you have a great day. Good night.